Hello everyone and welcome to a new video. The topic we are going to learn today are the properties of whole numbers, namely the closure property, the commutative property, the associative property and the distributive property. Now before I can proceed with the details, I would request you to kindly subscribe to my YouTube channel if you have not done yet. Please do not forget to press the bell icon. Besides that, you're going to find the link of Telegram. You can join the same so that you get updates immediately when some new video is released. So on this note, let's move ahead and study the various properties of whole numbers. Now before that, a quick recap of the numbers over here. So you have the natural whole numbers, integer, rational number. There is an entire video dedicated to this, including rational, irrational, etc. So you can go and see that video separately if you want in details, but I'll just do a fast this thing to recap. Natural numbers. What are natural numbers? Numbers which use for counting, starting from 1 till it can go anywhere until infinity. Then whole numbers include all the natural numbers, but additionally a zero is there. Integers are a set of all whole numbers, but it can have negative numbers also. And rational numbers are numbers which include integers, whole numbers, natural numbers, and they can be expressed in the form a upon b, where b is not zero. So let's move ahead and understand the properties of whole numbers first. So the first property what we are going to learn is the closure property. So what does this property state? The closure property states that when you perform an operation such as addition or multiplication on any two whole numbers, the result will also be a whole number. What this means is that when you add two whole numbers, or when you multiply two whole numbers, the answer will always be a whole number. And if it holds true, you call it that it is closed for addition or closed for multiplication. Whereas in case of subtraction or division, it may or may not be a whole number. That means sometimes it can be a whole number, sometimes it cannot be a whole number. And in that case, you say it is not closed for subtraction or division. So let's check out a few examples. So here is an example of addition. So when you add 0 plus 4, you get 4, which is a whole number. So you call it closed for addition. In case of subtraction, supposing we minus 5 from 4, you get a negative this thing. So you see negative 1 is a integer over here. It's not a whole number. Hence you call it not closed for subtraction. But if you just reverse, you can see over here 5 minus 4 will be positive 1. So sometimes it may give you a whole number, sometimes it may not give you a whole number. But even if it violates once, you're going to call it not closed. So subtraction is not closed for the closure property. Now next we move on to multiplication. So multiplication 0 into 4 is 0, or which is a whole number. Let's say you multiply 4 by 3, you're going to get 12, which is a whole number. So you call it closed for multiplication. And finally division. Now if I divide 3 divided by 4, you get 3 upon 4, which is a rational number, and hence it is not a whole number. Hence you say it is not closed for division. Next we move on to the commutative property for whole numbers. What does it state? The commutative property states that the order in which you add or multiply two whole numbers does not change the result. What it means is, let's say you do an addition of 2 plus 3, or you do an addition of 3 plus 2, the answer will always be 5. It won't change. Likewise in multiplication, let's say you multiply 2 into 3, get 6, or you reverse the order, 3 into 2, you're going to get 6. So if this is the case, you call it true for the commutative property, and if it doesn't, it doesn't hold good the commutative property. So the addition over here, a plus b is equals to b plus a. So let's say you add 0 with a 4 or a 4 with a 0, your answer will be the same. So LHS will be the same as right hand side, hence you call it true for addition. Let's take an example, subtraction. So if you subtract 4 minus 0 or 0 minus 4, so 4 minus 0 on the left hand side is 4, and 0 minus 4 on the right hand side is a negative 4. So you see both the answers is not the same. The LHS is not same as the RHS. So subtraction does not follow the commutative property. Then move on to multiplication. A into b is equals to b upon a. Let's say a is 0 and b is 4. So when you multiply 0 into 4 or 4 into 0, on the left hand side 0 into 4 is 0, RHS 0 into 0 is 0, which is true, hence it is true for multiplication. Finally, for division, A divided by B and B divided by A. So 4 divided by 2 and 2 divided by 4, you see on the LHS you'll get 4 divided by 2 is 2, and on the RHS 2 divided by 4 is half. So when you interchange the order, it does not hold true, hence commutative property does not hold true for division. So let's take the next property, which is the associative property for whole numbers. So what does this say? The associative property states that the way in which the numbers are grouped in addition or multiplication does not change their sum or the product. What it means is, let's say there is a combination of 3 to 4 numbers, and when you club them and when you change the order of clubbing for both addition and multiplication, it won't change the output. Let's check it out with an example. So let's take 3 numbers over here, whole numbers A, B and C on the left hand side and right hand side. Now what we're going to do is we're going to club B and C over here on the LHS, and on the right hand side you're going to club A and B, and let's check out with a few examples over here. So here A, B, C values are 0, 4 and 5, and on the right hand side what we are doing, you're clubbing B plus C and you're clubbing A plus B. Now to solve this, you need to always follow the BODMAS rule. If you have not clear about your BODMAS, you can check out the video on BODMAS. Make sure you follow the BODMAS steps. So first is bracket. So on the LHS you'll have 0 plus 9, which is over here, and the RHS you'll have 4 plus 5. So you see LHS plus RHS, 9 is equal to 9, hence the associative property holds true for addition. Next move on to subtraction. A minus B minus C is equals to A minus B minus C. You are again doing a grouping of 2 numbers separately, and you are checking out the result. So on the these are the numbers over here. 4, A is 4, B is 0, C is 1. So again you solve the bracket first. So 0 minus 1 you're going to get -1, and negative into negative you're going to get positive over here. So 4 minus -1 you're doing over here, and on the right hand side 4 minus 0 is 4, so 4 minus 1. So negative and negative is positive, 4 plus 1 is 5, and in the right hand side 4 minus 1, which is not equal to 3, hence the subtraction does not follow the associative property. Next we move on to multiplication. A into B into C is equals to A into B into C. You are having 3 numbers again over here. You're grouping 4 into 5 here, and then you're changing the grouping order over here. So we solve the bracket first. So 4 5s are 20, and here you'll have 4. So 0 into 20 is equals to 0 into 5. On the LHS you have 0, on the RHS you have 0, which is true, hence you call the associative property holds good for multiplication. Let's check out for division. In case of division, you have A divided by B divided by C on the LHS and right hand side. The grouping is changed. You have B divided by C over here and A divided by B. So let's check out an example. You have 100 divided by 25 divided by 5. So A is 100, B is 25, C is 5. So what you're going to do over here, you're going to again follow BODMAS. So you're going to have here inside the bracket you're going to have 5, and 100 into 5 over here. So when you solve this over here, 100 divided by 2, 25 divided by 5, what's going to happen is this is just going to be the reciprocal over here, 5 upon 25, or you can straight away solve this. So 100 divided by 25 divided by 5 would be looking something like this. It would be 100 into 20 over here, 5 upon 25. So 5 1s are 5, 5 5s are 25, or you could solve it like this also. 25 divided by 5 is over here 5 over here. So 100 divided by 5 would be 4, and on the right hand side we have 100 divided by 5, which is 4, and divided by 5 over here. So on the LHS you have how much? 20. On the RHS you have 4 upon 5. So this does not hold true, hence the associative property for whole numbers also does not hold true. Finally we move on to the distributive property for whole numbers. So what does it state? The distributive property states that the multiplication distributes over addition or subtraction. So let's check out the first example, multiplication over addition. So a into b plus c is equals to a into b plus a into c. So what it means is a multiplied by b over here. So you have a into b over here, the plus sign in between, and a multiplied by c. That means the multiplication is distributed first over b and then it is distributed over c, and the addition sign is in between. Let's check an example over here. So this is an example. We're going to solve the brackets first again. 4 plus 5 is 9. This will be 0. This will be 0. So 0 into 9 is 0 on the LHS, and 0 plus 0 is 0 on the RHS. So multiplication is distributed over addition, then that's the distributive property over here. Now let's check out multiplication over subtraction. You have a into b minus c is equals to a into b minus a into c. How? A into b over here, negative sign in between over here, and a into c. Let's check an example. So we check the brackets first. 5 minus 4 is how much? 1. And 0 multiplied by 5 would be 0, and 0 into the 0 would be 0. So your answer is 0 1s are 0, 0 minus 0 is again 0, and hence you can see that multiplication distributes over subtraction. Now let's check the whole numbers in a tabular form. So if you just see that it is similar to the closure for the natural numbers, obviously it will be, because there is just an addition of 0. So you can see over here addition and multiplication, all properties holds good with them, but in case of the closure, the commutative and associative property, only the addition and multiplication hold good. Rest like subtraction and division do not hold good, and distributive property distributes over addition and multiplication. So I hope that this was clear to you, the properties of whole numbers over here. If you have any doubts, you can always ask in the comments section. Do like this video, do share this video across, and until the next video, take care and be safe.